Okay, so this is now what statistical test we have to perform. Last time we saw that if your outcome variable, that is your dependent variable, it is categorical and your independent variable is also categorical, you will go for a non-parametric test, that is the chi-square test. Okay, predictor variable means that is the independent variable. If we are seeing between anxiety levels, like if you are saying some people have mild anxiety, moderate anxiety, and that is a categorical variable, and we are assessing determining between the gender and anxiety level, that would be the chi-square test. Okay, if for example you have the predictor variable is gender and your outcome variable, that is the levels of anxiety, they are quantitative, we are measuring them in 1 to 3, so you do a comparison of means test. Okay, and how many means are compared? If two means are compared, then we will go for the t-test, and if more than two groups, then we will go for ANOVA. So in this session we will be dealing with this stuff. In the next session we will be dealing with regression and correlation. I will give you further examples, and then we will see how we are gonna do that. In last session we discussed about the chi-square test. Okay, so what is a t-test? One sample t-test, we decided that if your one variable is categorical and the other variable is quantitative, we go for a t-test. Okay, and t-test is used only if we have the data is parametric. One variable is numerical and the other one is categorical. The categorical is not paired and the group number is 1. Okay. And is the average height of women greater than 160 centimeter? If you want an answer to this question, or if we have anxiety levels of females and we want to see are the anxiety levels of our population greater than the anxiety of an average population of Pakistan, or is the mortality that has been recorded at my center, is it greater than the average mortality of Pakistan? I will go for one sample t-test. Okay, one sample t-test is used if we have just one group, we have just the data of one variable, that is the anxiety levels of female, nothing more, nothing less. Okay, just one variable. So what we will be comparing it with, we will be comparing it with the average value that has been already decided and kept as the standard in the previous articles. Okay, so let me run this test for you and then we will move on to the next one. Okay, suppose we have the weight. Here was a weight, let's just copy it there. Okay, insert variable. Okay, so I have copied it here. My weight is here and the gender. I have just two groups. Suppose I have just this group, female and the female and their weights. Okay, and I want to see that the mean of is the mean of my females, the weight of the mean weight of my female, is it more than the weight of an average Pakistani female or not? Okay, so what will I do? I will go here in analyze and in compare means. I am not going to compare means, I am going for compare the one sample t-test. And I will put the weight here. Okay. And what I will do is I will test value would be around, my test value would be I say Pakistan mean population weight is around 55 and I will run okay. So now it's showing me that your mean weight is 58. So according to the one sample t-test, it has come around not significant. What is the significance? What would be the significant would be if it is less than 0.05. If it is less than 0.05, we would have said that there is a statistically significant difference between the weight of our females and the weight of the females of general population. Okay, and but it is not significant, so we can say that the weight of our female is not different from the weight of the females of Pakistan. I will just run another test for you, for your guys' sake. Once again, just summarizing it, the thing is, if we want to compare the quantitative variable of our population just like the anxiety levels, the pain levels, the depression levels, okay, that are numerical, and we want to compare it with the average of the population, the standard. We will choose a one sample t test, okay. And when reporting the one sample t test, we would state that the mean and the standard deviation of our population is this, and it is not significant. If it is significantly less, more, or different from the general population, and then we will add the value of the t-test, the degree of freedom, and the p-value. Okay. First, we will write that our mean came out to be this, and the mean of Pakistani population is this, and then we will write the degree, the test statistic. This is the test statistic. This is the degree of freedom, and this is the significance value. That is the two-tailed significance value. Why we go for the two-tailed? That means that the data has been analyzed in both the directions, in the increasing direction and the decreasing direction. This is more of the theoretical stuff. You can study it later on. We are just dealing with how to apply the t-test. Okay. So this is the statistic of the t-test. This is the degree of freedom, and this is the significance. The degree of freedom is how much degree the data has, like that, just like the confidence intervals levels. And this is the mean of our population. It is not that much statistically different. Okay. Why? Because we kept the mean as 55 of our population, and here it is 58. Okay, so let's run another test that is on the pain levels. This is the pain levels, and but it is categorical. What we will do is we will create another variable, and now it is numerical. What I will do is I will compare the means, one sample t-test, and I will put it back here. I will add the pain. And I say that an average pain a Pakistani feels is zero. Normal, okay? Normal person does not feel any pain in their body. So whatever is more than this, uh, that is not normal, okay? So suppose I am taking this variable. Of course, I will have to see how much pain the medical students are suffering from according to my parent article that has already been done before. We discussed about the parent article in our previous lectures. Okay, so I just put a value of, or I can say 2. Okay, some medical students face pain in their joints, and our pain of fibromyalgia came out to be 2, and I press OK. Now it's saying that your mean pain is 2.5, and the value is still not significant, especially because of our small sample size. But here is the t statistic, this is the degree of freedom, and this is the significance value. And this is how I will report my one sample t test. Okay, the next we have is the independent sample t-test. Okay, first let's go to the theoretical stuff, and then we will move on to the okay, this was about the one sample t-test, and it compares. Okay, so the independent sample t-test is used when one variable is numerical, for example, once again our weight, and one is categorical, that is the male and the female, and with two unpaired groups. What, why are they not paired? Male and female are not paired. We talked about the pairing of the groups beforehand, before and after. Okay, so independent sample t-test is used when they are not paired and there is a numerical variable. Its corresponding non-parametric test is Mann-Whitney test. Okay, and there are different ways to apply the non-parametric test, but we will not be going into their details right now. We will be just dealing with the parametric test. You can just scroll through the YouTube and you will find the video. It's just like a 2-minute video on how to apply the Mann-Whitney test. Sometimes the SPSS automatically applies this non-parametric test when the data is not parametric. Okay, are men taller than women? Are men heavier than women? We'll be checking that. And is there more load shedding in one area as compared to the other area? Okay. They are not grouped, they are not paired, but we want to compare them. In the previous one, we were comparing our levels with the standard. But now, what we are doing, we are comparing one thing with the another. And how will we report this? We will just report this. An independent sample t-test was run. It was found that the score in one group were not significant as compared to the other, and stuff like that. Let me just do it. So we are once again back with our analyze, compare means, independent sample t-test. And here we have the weight. Sorry. And options, confidence interval we have kept 95 because we have to keep it 95. Okay, so in the test variable we have added weight, and here in the grouping variable we will add gender. It's asking me identify the genders. We wrote that group 1 is male and group 2 is females. You have to be case specific, but however you have written here, you have to write it here. Okay, continue and okay. So it's saying that the mean weight of male is 64 kg and the mean weight of female is 53 kg. Okay, and their standard deviation is also shown. Now, what about the p value? The p-value, we have to assume that there is variances are assumed. That's the standard that we use. Variance and standard deviation, that's like a very detailed topic that you can go if you want to theoretically know this stuff. But for most of the times, we assume that our data is normally distributed and our variances are equal variances are there. This is the value of the t-test. This is the degree of freedom and the significance. We will be taking this one. It's 0.06. That is, there is no statistically different in the weights of males and females. But if it was less than 0.05, we would have said that there is a statistical difference between the weight of males and females. Okay. So one sample t-test and then we have run the independent sample t-test. Let's go for the next one. This is a pair t-test. What is a pair t-test? That one variable is numerical and one is categorical. Categorical is paired, that is before and after, okay? And group number is 2. And it's what is the corresponding non-parametric test? That is the Wilcoxon signed rank test. That's the non-parametric test of this pair t-test. Is heart rate different before and after exercise? Is the student knowledge of statistics before and after this workshop differ? We will use a pair t-test. Okay, and how we will be reporting it? Same way. Indicate a not statistically significant difference between the score before and after, and then we will add the t-test value and the degree of freedom df, and here is the p-value. In the brackets, we add the degree of freedom. Okay. And then we add the t-test value and then we have the p-value. Okay, let me run this test and then we will be moving on in the next session on ANOVA. Okay, so what we'll be doing here, okay, for the pair t-test, we need to have the data that is before and after. Suppose this is the weight. Suppose this is the weight before exercise. Weight before exercise. Okay, and we make another variable the same sort and we make this the weight after exercise. Or sometimes you even when you are conducting a clinical audit, you have to use this. Okay, what was the intervention, what were the levels before and what were the level after the clinical audit. Okay, and I will go into again into sorry, I will go into analyze and I will write compare means, paired sample t-test. It's asking me what is your variable one. I will say my variable one is this one before exercise, and my variable two is this one after exercise. Okay. Standard deviation, I need the corrected standard deviation. Also calculate the effect size in the options. I go for 95% confidence interval and okay. So it's saying that your mean weight before exercise was 58 and mean weight after exercise was also 58. Okay. And what about the standard deviation and the standard error? It's all given here. Okay. And it's saying because the data is completely the same, that's why we were not able to run the correlation and the t-test because the standard error or the difference was zero, because I just actually copied and pasted this data. Okay. So this is about the t-test. In the next session, we will be going through the ANOVA.